All right, now let's move on to 4 more of the points on the circle. Now, I know what I call them. Maybe they have an official name, but basically what I call them are the kind of the middle diagonal coordinates. See this one right here? That one right there. That one right there. That one right there. And that one right there. Okay? I call those the middle diagonal coordinates. The reason I call them the middle diagonal coordinates is because from the center, you would draw a diagonal line sort of halfway between these 2 points. Like a perfect diagonal line would go right to this point. Puts you right in the middle between here and here. Okay? So I call them the middle diagonal points. It doesn't matter what they're called. The only thing that really matters is that you're able to calculate or identify the coordinates of those points. Now let me show you something which you're probably already predicting I'm about to do, is that if you were to draw a radius from the center of the circle, let's remember that the center is at 7 and 9, because I got to erase that because I'm going to write some more stuff on here. So let's erase this. And here's what I'm going to do. I'm going to take a 45, 45, 90 right triangle, and watch this. It's going to fit. See, the hypotenuse of this 45, 45, 90 right triangle is equal to the radius of this circle. Look at that. Isn't that perfect? Fits right in there. And so I could identify the radius. I could draw a diagonal line from here to here, and then draw a vertical line down here and a horizontal line out from the center. And what will happen is that what this is basically going to show me is it's going to show me how far away this dot is from this dot in a horizontal direction and a vertical direction. Now we know that the radius of this circle is 5, right? So the radius is 5. That means that the hypotenuse of this triangle is 5. And if the hypotenuse of this 45, 45, 90 triangle is 5, what that means is that this middle diagonal, that middle diagonal point, is at a 45-degree angle from the center. And that middle diagonal point will always be at a 45-degree angle from the center. Similarly, this middle diagonal point is also at a 45-degree reference angle from the center. If we use the reference angle from this horizontal line here, this is a 45-degree angle. Similarly, over here, this middle diagonal, also a 45-degree. And lastly, this middle diagonal is also a 45-degree angle. Okay? And so we can identify the coordinates of those 4 middle diagonal points by using the proportions, the lengths of a 45, 45, 90 right triangle. Now, if I have a 45, 45, 90 with a hypotenuse of 5, we know that the hypotenuse of a 45, 45, 90, if the legs are equal to x each, then the hypotenuse is the square root of 2 times x. And so all I have to do here is take the 5 and say that 5 is equal to the square root of 2 times x, then divide by the square root of 2 on both sides, then rationalize the denominator by multiplying by the square root of 2 over 2, top and bottom, and I would get a leg length of 5 square root of 2 over 2. And here's what's interesting. I want to show you something. This is a shortcut. This length right here will always be equal to the length of this horizontal length, and the vertical length will always be equal to the radius times the square root of 2 over 2. Always. All you have to do is put the radius right in there. So if this was a radius of 7, the length here would be 7 square root of 2 over 2 every time. So that's your shortcut. You might want to write that one down. So the distance here is 5 square root of 2 over 2, and the vertical distance here is also 5 square root of 2 over 2. And so now if I started at the point 7, 9, 7 comma 9 here, right? All I have to do is add this value. I'm going up from 7 over here. by 5 square root of 2 over 2. So it's 7 plus 5 square root of 2 over 2. That's my x-coordinate up here. Let me go ahead and write that. It's going to be 7 plus 5 square root of 2 over 2. And then the y-coordinate is going to be 9. And then I'm going up, so it's plus. 9 plus 5 square root of 2 over 2. Let me move this radius over here. Radius equals 5. So I've got 9 plus 5 square root of 2 over 2. There we go. Those are the coordinates of that point. You do not have to simplify them. Just leave them like that. Okay? Now, if I go over here to this next point right here, get rid of this. The radius is still 5, so that means the length here is 5 square root of 2 over 2, and the length here is also 5 square root of 2 over 2. And so all I have to do for this x-coordinate, the x-coordinate goes left by 5 square root of 2 over 2, so all I have to write is 7 minus 5, oops, I need to put a 5 in there, 7 minus 5 square root of 2 over 2, that's the x-coordinate. The y-coordinate is still positive. We're going up from 9 because this is a height of 9. This is the point 7 and 9. So this is 9. So if I'm going up, it'd be 9, 10, 11, 12, right? But I'm not going up here. I'm going up over here. And how high am I going? From here to here is 5 square root of 2 over 2. So that's 9 plus 5 square root of 2 over 2. That's the y-coordinate. Notice how this coordinate right here relates to this coordinate. It's the same coordinate, except this is a minus instead of a plus, right? We're going to see that pattern repeat itself down here. Let's go down to this middle diagonal point down here. So, the radius is 5. That means that this distance on the 45, 45, 90 is 5 square root of 2 over 2. And the vertical distance is also 5 square root of 2 over 2. From the x-coordinate of 7, we're going to the left, so we're going to subtract to go this way. Remember how we subtracted 5 to get 2 over here? Well, we're only going this far, and we're going to subtract 5 square root of 2 over 2. So the coordinate down here, the x-coordinate, is 7 minus 5 square root of 2 over 2, comma. The vertical, we're going down from 9. We're going, this is a y height of 9, but we're going down, so we're going to subtract from 9. So we're going to do 9 minus 5 square root of 2 over 2. And so we're done there. And now for the last diagonal coordinate, over here, middle diagonal coordinate, let me get this out of the way. Radius is 5, so that means the length of this leg is 5 square root of 2 over 2, and the length of this leg is also 5 square root of 2 over 2. And so now, this point, we're going from 7, the x-coordinate is going to be from here over to here. Remember, x-coordinates go sideways, right? So and if we're going to the right, we're adding, we're going up. You know, on the x-axis, right, we go, 1, 2, 3, 4, 5, 6, 7, and then if we were to go up 2, it would go 7 plus 2, 8, 9, right? So that's what we're doing. We're going over to the right. So we're adding. We're adding distance. And the distance we're adding is 5 square root of 2 over 2. So we got to add that to 7. To the x-coordinate is 7. So this is going to be 7 plus 5 square root of 2 over 2, comma. And then the y-coordinate, which is 9, but now it's going down, so we have to subtract. It's going to be 9 minus 5 square root of 2 over 2. And so look what we have here. The middle diagonal coordinates are all 7 and 9, 7 and 9, 7 and 9, 7 and 9, right? They're all relative to the center. But up here, we have added 5 square root of 2 over 2 to both of them because we went positive, positive. Over here, we went negative, positive, so we subtracted 5 square root of 2 over 2 and then added 5 square root of 2 over 2. Down here, we went negative, negative, so we subtracted 5 square root of 2 over 2, and again subtracted 5 square root of 2 over 2. And then over to the right here, we went positive, then negative, kind of like quadrant 4, right? Positive, negative. We went positive, negative, so we added to the x and subtracted from the y. I recommend, if you got kind of confused here, now that you've seen the end of it, it may make a little more sense. What I recommend that you do is go back and rewatch this video. It's only about 10 minutes, and I'm sure you will probably learn a lot by seeing it again. Now, just so you know, let's say then, I'm going to do something as an aside. If I knew that there was a circle that had a center at 411, and it had a radius of 13, and you wanted me to identify the 4 middle diagonal coordinates, I know that these would be the 4 middle diagonal coordinates. The first one would be 4 plus 13 square root of 2 over 2, and 11 plus 13 square root of 2 over 2. The second coordinate would be 4 minus 13 square root of 2 over 2, and 11 plus 13 square root of 2 over 2. The third coordinate would be 4 minus 13 square root of 2 over 2, and 11 minus 13 square root of 2 over 2. And the last one would be 4 plus 13 square root of 2 over 2, and 11 minus 13 square root of 2 over 2. Did you see how fast I did that? These are the 4 coordinates of the middle diagonal points on the circle that has a center at 411 and has a radius of 13. Okay? I hope that little exercise right there helped a little bit. Now, if you went back and watched the whole video, boy, I think you would really understand and you'd be able to answer every single one of these questions without even drawing a circle. Okay? All right. Next video, we're going to move on to these last 8 points. These are actually at a 30-degree angle and at a 60-degree angle.